5.2 is perpendicular and angle bisectors, and we're going to just use properties of both of those to solve different things. Here's your first theorem today, theorem 5.2, perpendicular bisector theorem. Just do the words. And if you're looking in your book, the one after that, converse of the perpendicular bisector theorem, again, just do the words. Let me see if there's more. That might be it. Oh, yep, there's quite a few. I'm going to have you do those on your own time today, I think. Just do the words. And converse of the angle bisector, just do the words. Okay, so I'm going to keep talking, and you guys have plenty of time to do these. Actually, you kind of don't. They need to be done by tomorrow, but I don't want to take up your time to do those. So I'm just going to kind of keep rolling. Theorem 5.2, perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So if a point, like this point P right here, is on the perpendicular bisector, how do we know that? Because first of all, it bisects the sides because those two are the same. It's also perpendicular because of that right angle in the middle. You have to have both those things. If that happens, then this length right here is the same as that one right there, which kind of makes sense. The converse of that, if you know that the two, it looks like the hypotenuse lengths of the triangle are the same, then you also know that it is a perpendicular bisector after that. So the converse is a little bit harder to see, but when you look at it, these two are given to you first. If those two are the same, here's how I think about it. If these two are the same and we cut it in half and fold it, wouldn't everything else kind of be the same too? It would be a right angle if we cut it in half and fold it. It would also bisect it as well. So what is the length of AB? So they're going to give you some equational things. You guys just need to figure out what to do with them. So it is a right angle in the middle, so it's a perpendicular. It also bisects it because AD and DC are the same. If we know both of those things, this is the same as that. Okay? If you think about it like this, if you fold it in half, would it look the same? If it would, then just set them equal, whether it's equational or not. So 4x equals 6x minus 10. I would subtract 6x from both sides. You get negative 2x equals negative 10. X would be 5. And it does say what is the length of AB, so we do need to substitute it back in. So I'm looking at AB. It tells me to take whatever x is and multiply it by 4. So AB is 20. So don't forget to plug it back in, especially on these. They probably ask for that same thing. Would it have mattered if you plugged it into BC? No, because they're the same, but pick the one that looks like it is, that length. Distance from a point to a line. The length of the perpendicular segment from the point to the line is the shortest segment that you are looking at. Angle bisector theorem. If a point is on the bisector of an angle, then the point is equidistant from the sides. So with this one, you know that this little angle right here, those two are the same because it bisects that angle. And you also have these perpendicular lengths. Then you know that this one is the same as that one. So again, it's one of those that if it looks the same right away and you fold it in half, everything else kind of about it must be the same. That's kind of how I think about it. But if you have to state the theorem, of course, here you're given the angles are congruent first, then you show the sides. The converse is the reverse of it, where they give you those sides or those legs that are the same first, and then you can say that the angle is a bisector. Okay, so on this last one here, problem 3, what is the length of RM? Okay, so they want the 7x side. So we have the right angles. We have that these two angles are the same. So 7x must equal 2x plus 25. We subtract 2x from both sides, and we get 5. But they also say what is RM. So we plug it in and get 35. So I'm looking for equational things like this. Solve them however you solve them. Get the x value and then plug it back in. I am not looking for just the 35. You have to show everything. Okay, so it is important to kind of go with whatever that theorem is. Okay, so grab a piece of paper. And we're going to do a few different things here. So label this one, got it, number 1. You do not have to redraw the picture. You can just go right off of your paper, but I need equations and things to solve it. So we are looking for what is the length of QR. Go ahead and do this in your notebook, and we are going to hand these in right after we're done. You shouldn't be paging through your book. Just go off of whatever you have in your head right now.